So this is a column where there are various forces acting at different levels. There is an 8 kilonewton force acting at this point. There are two 6 kilonewton forces acting at the brackets situated here. Similarly, 4.5 kilonewton forces acting on the brackets around here. Okay, so we need to find out, according to this problem, the internal normal force acting on the cross section that passes through point A. Okay, in order to do this, we will have to section as shown over here. I am going to draw a skeletonal diagram, okay, of the column. So this is the column. This is the cut section A. Let's now draw all the forces on this. Mind you, this is a free body diagram. There are two 6 kilonewton forces acting at different points. Let's name this as B, this as C, and this as D. Okay, there are two more forces acting here, 4.5 kilonewton and 4.5 kilonewton. Okay, having cut this, we need to insert a normal force. Let's call this as N. Now from the free body diagram, we can say, if this is the direction which is y direction, we can say sigma Fy equals 0, upward being positive. That implies minus 8, minus 6, minus 6, minus 4.5, minus 4.5 kilonewton, minus N is equal to 0. These two 6 kilonewtons appearing because of these two forces. Similarly, 4.5 kilonewton. This gives us N is equal to minus 29 kilonewton. And as you can see here, this is a force, the normal force that is acting in the direction as shown, equal to 29 kilonewton. And that's how we find out internal force. Here we are also asked to plot the internal normal force along the height of the column. So let's just see how we can plot this. In order to do this, I am just drawing these lines. These lines are drawn mainly because, as you can see, the forces are actually acting at these points, and therefore any change in the internal force will occur after these forces have been applied at various levels. And therefore let's just draw the internal force diagram here. Okay, now if I cut in this section and take the free body, it's not very difficult to find out that the force, internal force acting in the upward direction is equal to 8 kilonewton. So I'm just going to use this direction as positive, and therefore I will have the internal force to be 8 kilonewton in the negative direction. Okay, so this is minus 8 kilonewton acting from this point till this point. Okay, once I reach this point, there are two 6 kilonewton forces additionally adding up, which means this will get into 20 kilonewton. So this is 20 kilonewton. At this level, again 9 kilonewtons get added up, and therefore you have 29 kilonewton force acting like this. I'm just representing these as negative forces, basically acting upward. Later on we will understand the sign convention related to internal forces, but for now I've just taken a direction and plotted this.